Hello, everybody. It's Sunday, November 1, and this video is going to try to cover the lesson. Um, and we'll also talk about problem number 3 in this, and we'll tell you if you want to skip. If you were in Zoom last week, you can skip the beginning parts of this video, and we'll leave a note as to where to find number 3 in the rest of the problems if you only want homework help. But if you want to review what we learned last week, feel free to watch the entire video. Okay. But anyway, for those who were not on Zoom last week, or if you want to review what we learned last week, basically we started off with a do now. And the assignment is called percent of a quantity. If you can see on the top left right here, percent of a quantity. And number 1 was talking about this question right here. The purple bar below represents 100%. So pretend this is 100%, this purple bar. And then the blue bars below represent other percentages. So we don't know what percent this is. We don't know what percent this is. And basically 1A was talking about what do you notice or wonder about the blue bars over here? What percent do you think each of the blue bars are? So you're taking a guess as to what percent these are. And what do you notice and wonder? Now, we can take a look at what your classmates in one class said. So if we go to, if we go here, you can see what some of your classmates did. Some of your classmates did some guesses. Some of your classmates did some divisions here. They were splitting the bars. And you can see some answers on the right. And you could see what your classmates were doing to these bars. Okay. And really, when you're talking about noticing and wonderings, there really is no, there's really no wrong answer here. You're just giving your best guess. And what do you notice and wonder? And what do you think the answers are for that? So that was number 1 in this task. After we reviewed the answers, we talked about how, and we talked about this previously, but there are many ways to express a portion of something. And a portion is just a fancy word for parts. So we talked about how fractions, decimals, and percents are 3 different ways to express a portion or a part. And today, and this lesson focuses on percents. So this whole lesson is about finding percents of numbers using a diagram. Now, here's that 100% bar again. And in Zoom, we talked about what if we took that 100% bar and we cut that up into 10 pieces like this. And so we asked the class, well, if you take a look at this small piece right here, how many percent is this piece? How many percent is this piece? How many percent is this piece? And some people, and a lot of people, so basically the question is how many percent does each smaller bar represent? And some of your classmates came up with 10%. And so we asked your classmates, how did you all get this? Well, some people said if you take 10 and you multiply it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 groups of 10% is 100%. 10 times 10 is 100. Similarly, other people did division. 100 divided by 10 pieces equals 10%. 100 total divided by the 10 pieces equals 10. And so there's a couple ways to get the 10%. Okay. So each smaller bar represents 10%. We talked about how do we use the gray rectangle to represent 30%. Well, just knowing what was done earlier, remember each bar represents 10%. So that's how you so this gray rectangle is how you represent 30%. And you can also think of this whole picture as a health bar. This is 30% health. And another way to label this is to go like this. 0% is right here. If we make it this far, it's 10% health. If we make it this far, it's 20% health. And if you go this far, it's 30% health. 40, 50, 60, 70, 80, 90, 100. Okay? So the labeling is very important to visualize all of this. Okay? It can get very complicated, so labeling is really helpful. Now, let me go ahead and clear this out if I can. Let me see if I can erase the whole thing here. Oh, okay. Let me see if... All right, there we go. In an imaginary world, Mr. Zuniga wants to pay you 50% of $30 for doing schoolwork. How much money is that? So if we do our visual again, 0, 10%, 20%, 30%, 40%, 50%, we're talking about this part right here. So this is the 50% part. In an imaginary world, Mr. Zuniga wants to pay you 50% of $30 for doing schoolwork. How much money is that? So some of your classmates said, hey, 50% is half. And if you visualize this, I just colored in half of this whole thing, okay? So we want to know what is half of 30? What's half of 30? And so some of your classmates said, wait a minute, half of 30 has to be 15. And some of your classmates said, well, half is the same thing as splitting it in two. And so that's how they got 15. And so the answer is 50% of 30 is 15. Okay. That's just one way. Dividing by 2 is just one way to get 15. Okay. Now, 50% is relatively easy because it gets harder when we talk about things like this next part here, when we talk about things like 40%. Okay, so now it's getting a bit complicated. And so we did talk about this kind of problem, but also we're practicing these kinds of problems in breakout rooms. So now I'm gonna go in this video, going to go straight to what we did in this assignment. So number 2 is just norms, but number 3 now is what we're going to work on together for this one. So I'll go ahead and read number 3 to you. Douglas and the Nutty Chocolate Bar. Douglas has a chocolate bar, and you can imagine this purple rectangle as our chocolate bar. There are 50 peanuts in total, equally spread out all over the chocolate bar. So imagine that there's peanuts all over here, and they're just spread out evenly. And there are 50 of these peanuts, okay? Douglas only eats 30% of the chocolate bar. How many peanuts did he eat? Okay. Now, here's a few things to understand. In this whole chocolate bar, there are 50 peanuts. In this whole chocolate bar, there are 50 peanuts. but Douglas is only going to eat part of it. And our question is going to be, how many peanuts did he eat in the 30%? Okay. Now, this visual, just keep this in mind, but I'm going to erase it because we need to figure out how many peanuts there are, but I'm going to do something that's a little more accurate for this, okay? So I want to show what 30% is. And I'm not sure how I'm going to estimate 30%. I mean, not estimate, but I don't know how I'm going to show exactly what 30% looks like unless I cut each of these into the 10%. Okay, so this reminds me of what we did earlier with this kind of problem here. I want to cut this, I want to make this whole picture right here so I can accurately show 30%. Okay, so what I'm going to do is I know 50% is right around here. Okay. Now let's change the problem a little bit. So sometimes in math, it's okay to change the problem a little bit to help us understand. What if Douglas ate? What if Douglas ate all of the chocolate bar? What if Douglas ate 100% of the chocolate bar? All right, let's represent that. 100% is right here. What if Douglas ate all of the chocolate bar? How many peanuts is that? I'm going to put P for peanuts. If Douglas ate the whole chocolate bar, how many peanuts is that? Well, it's going to be 50 peanuts. And so what I'm deciding to do is I'm labeling percent up here, and I'm going to label peanuts down here. 100% of the chocolate bar is the same as eating 50 peanuts. Eating 100% of the chocolate bar is the same thing as eating 50 peanuts. Okay? Now, I'm going to go here right at the beginning. What if Douglas, so now I'm thinking about a different problem, or a similar problem actually. What if Douglas ate none? What if Douglas ate 0% of the chocolate bar? How many peanuts did he eat? He would eat no peanuts. If you eat nothing, then you're not going to eat any peanuts. Okay. If you eat all of the chocolate bar, you've eaten all of the peanuts, and there's 50 total. Okay. Now what I'm going to do is let's go back to the real problem. So we were thinking about pretend problems, and now we're going to talk about the real problem. I want to show 30%. Okay. So I'm going to do that. I'm going to do that trick now where we're going to cut everything into 10%. Okay. So here is where 50% would be, because 50% is half. Okay. I'm going to cut this into 5 pieces. And I'm just going to take my best guess. 10%, 20%, 30%, 40%, 50%. Okay. 60, 70%, 80%, 90%. Okay. I want 30%, so I need to mark this fairly clearly here. Here's 10%. Here's 20%. Here's 30%. Okay, I'm going to stop right there. So, yay, we have our 30% now. We know it's somewhere around here. But the question is, how many peanuts did he eat? So, he ate 30%. So, how many peanuts is that? That's our question mark. That's what we're trying to figure out. Okay. Now, to do this kind of question, to do this kind of question, it would help us if we knew what goes in each of these boxes. It would help us to figure out what goes in each of these tiny boxes. And I'll tell you, and if it doesn't make sense right now, we'll tell you why it was important to figure out these tiny boxes, okay? So we know that each of the tiny boxes represents 10%. Here's 10% right here. Here's 10% right here. Here's another 10% right here, 10%, and so on. All of these little boxes are 10%, okay? You don't have to label every single one of these, but I just want you to understand that all of these are 10%, okay? So the question is, how do we figure out what goes in each of these boxes? How many peanuts goes here? How many peanuts goes here? How many peanuts goes here, here, and here, and here, and so on, okay? And we can go back to what we were talking about earlier when we said, hey, this whole chocolate bar has 50 peanuts. Well, this whole chocolate bar has 50 peanuts and it's split into 10 pieces. So if we divide it by 10, we would get 5 peanuts in each box. Okay. Is division the only way to do this? No, because we could have just said 10 times 5 equals 50. Okay. So wait, there's 5 peanuts in a box. So each of this is 5. Okay, I'm going to mark that. Notice how labeling helps us understand. Okay. Each of these little boxes has 5. All right. Now we're getting closer to the mystery. Okay. So why did we do all of this work? Well, okay. Let's go to the question again. How many peanuts did he eat? Well, wait a minute. How many peanuts did he eat? We're talking about 30%. So let's circle what 30% looks like. It's this part. This is our 30% right here. Okay. This is our 30%. So how many peanuts is 30%? 5, 10, 15. Okay, so Douglas ate 15 peanuts. Okay, all I did was added the 5s, or 5 times 3. So this is what 30% looks like. Okay. 3B says show how you figured this out using the text box on the bottom or a sketch pad on the left. Does it mean that you have to do both this and this picture? No. Okay, you have a choice of either one. And so for me, I'm skipping this part because I already did it here. Okay. But some people are not going to skip this because it helps you remember what you did for this kind of problem. Okay. So it's up to you. You can skip this if you want, or if you find this helpful so you can remember what we learned, do it. Okay. But before we end this talk on number 3, why did we do all of this work? Okay. Why did we do all of this work? We did all of this work because 30% wasn't easy to find. And knowing the 10%, like we needed help. We needed to get these 5s. Getting these 5s helped us figure out the 30%. Okay, 10% is 5 peanuts. And if we know that 10% is 5 peanuts, then we can figure out 20%. By the way, how many peanuts is 20%? 10 peanuts. Here's 20%. 20% is 10 peanuts. Okay, so these 5s help us figure out 30%. This 10% right here helped us figure out 30%. What if this question said 70%? What if this question said 70%? How many peanuts was that? Well, here's where 70% is. 50, 60, 70. If this question said 70%, how many peanuts is this? 5, 10, 15, 20, 25, 30, 35. 70% is 35 peanuts. Okay? But that was not the real problem. I just wanted you all to just keep understanding how to do this. Okay? I hope this helps. I hope this labeling helps. Really work on labeling it as much as you can, because visualizing helps, because there's so much going on in this problem. Okay? So, and then this is a method that we talked about Friday if you were in Team Bulbasaur, and Thursday if you're in Articuno. All right. So that was number 3. And then for those of you who missed out on number 4, there are about 90 sixth graders at Viz Valley Middle School. So pretend this bar represents the whole school. This is the whole school. And there's 90 students. 90 students. Oh my, okay, there we go, sorry. A recent survey showed that 25%, actually we had changed this to 20. Okay, so we're not doing 25%, we're doing 20. 20% listen to Billie Eilish. Okay, how many students listen to Billie Eilish? All right, there are many ways to do this kind of problem. Okay, but just know that, hey, if we started over here, so again, I'm going to change the problem to 0% first. What if 0% of the students listen to Billie Eilish? How many students is that? Okay, thinking now. If nobody listened to Billie Eilish, if 0% listened to Billie Eilish, then that means nobody did. Okay? But what if 100% listened to Billie Eilish? That means all of these students, all of the 90 students will listen to Billie Eilish, so it's 90 over here. Okay? All right, I want 20% because that's what the problem says. There's many ways to divide this bar, okay? You don't have to split it up in tens, but I'm going to. All right, I want 20%, and this is my way of showing 20%. Here's 50%. Okay, now I'm going to cut these into 5. 10, 20, 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay? And I know that each of these pieces represents 10%. And I'm going to go a little bit faster, but feel free to pause the video if you need to. All of these are 10%. Okay? If all of these are 10%, now I just want to know, what does this 10% represent? How many students go here? How many students go here? And so on. Okay. All right. What do we know now? How do we figure out what goes? How many students go in each box? How many students go in each box? Remember, this whole thing is 90 students. 90 students. And it's split into 10 equal boxes. So divided by 10 small boxes. What's 90 divided by 10? So it's 9 students in each box. Okay, so we know that this has to be 9. Okay, each of these has to have 9 students. Now, if you don't like division, I know some of you would have used multiplication. 10 times 9 is 90. So each of these 10% pieces has 9. 10%, 9 students. 10%, 9 students. 10%, 9 students. Let's go back to the question now. A recent survey showed that 20%, okay, remember we're ignoring the 25. Some of you had 25, okay? So we want 20%. I'm going to go ahead and highlight 20%. Here's 0%, here's 10%, here's 20. All right, how many students is this right here? Okay, how many students is this? How many students is that? So that has to be 18 students. Okay, so 18 students, 9 plus 9, or 9 times 2. So this 20% is 18 students. This 20% is 18 students. So how many students listen to Billie Eilish? You can just say 18 students. Okay, or 18. Better to type the word 2. Okay, so that's how you do that one. And we're going to leave you all to do the rest. Number 9 is just a friendly extension. It's an optional extension. You don't have to do it. But it's a fun challenge for those who want to try. Okay? I hope this video is helpful. Take care. And this work is due Wednesday. So we're giving you extra time. It was supposed to be due earlier, but we're giving you all extra time to work on it. Take care. Bye.